Hi everyone, and welcome to a presentation about 3D printing for role-playing games and miniature games. I'm Samuli and I'll be going through, let's say, a very basic beginner set about what 3D printing could offer for gamers and for both role-playing games and for miniature games. So what we will be going through here would be just some really basics about 3D printing, what it is, how they work, go through different 3D printer types that would be relevant for a hobbyist, about how to get started with 3D printing, where to get models to print, and also some 3D printing services. And as a little bit of background, so I'm an engineer. I've been working with 3D printers since about 2010 when I first kind of tinkered with them during university. And afterwards I've been using different kinds of 3D printers professionally for various prototyping needs and some other rapid manufacturing needs. And I also have a couple of 3D printers at home that I've been using especially to print miniatures and also to print a lot of terrain for miniature games. So let's start with the basics of 3D printing. 3D printing is actually more called additive manufacturing, which comes from basically it working by adding layer upon layer of materials to finally form an object, whereas the traditional manufacturing you would have a larger piece that you start cutting parts out of and then forming some sort of an item. 3D printers have been around since around 80s, but from a commercial hobbyist standpoint, the first real printer started to show up around 2009, and since then development has been extremely rapid with the quality, the manufacturing quality, the print quality has improved, prices have gone down pretty rapidly, and the development is still going strong. There are several different technologies that can be used for 3D printing, but from a gamer standpoint, let's say the most relevant will be FDM printing, which is fused deposition modeling, or resin printing, which kind of includes a few technologies, which would be stereolithography, and DLP, which is digital light processing. There are quite a few other technologies, but they have mainly use in industrial applications and professional workflows and are not really suitable for hobbyists. Then let's start going through a few both of the different printer types, the FDM printers and the resin printers, and what they could offer. So I would say FDM printers are, as you can see from the image, it's probably, if somebody thinks about 3D printers, FDM printers are what comes to mind first. So they are more or less the most common 3D printer type. They have a long history in consumer usage. They are generally pretty tried and tested technology. And as they are so common, it's always easy to find support. There are different models. There's a lot of standardized parts that are usable between different manufacturers, and it's easy to fine-tune the product to your liking. So how the FDM printers work? So basically they function by having a filament, which is usually a plastic one, which is fed to a nozzle which melts the material and extrudes it into the print surface, where it cools down and will finally form a finished product. For FDM printers, as they are really common, and you can find these pretty much even in your local hardware store usually, let's say the printing materials are fairly easy to source. A lot of regular stores in Finland stock these, and in general the materials are safe to use. A lot of them are even food safe, so you could even do stuff like kitchen utensils if you would like. In general, for FDM printers, the print quality is limited by nozzle size and layer height. You will always have some sort of layer lines visible, and of course you can vary the height which you are doing, but generally the finer detail, the longer your printing will always take. Also, the nozzle sizes available will limit how sharp and small details are achievable with this technology, as even with the smallest nozzles, let's say the smallest details, you are looking at roughly a 0.3 millimeter size pixel, which if you are working on super fine detail miniatures could be a limiting factor at times. But still, these are tabletop quality is still extremely easily achievable, and in most cases any sort of print markings are usually pretty much unnoticeable from an arm's length. So when you have your mini on the table, it can be quite hard to spot most of the 3D printing kind of artifacts that you will have around. Then some of for FDM printers, usually you are printing straight on the bed, and generally if the model is designed for 3D printing or with this technology, you can usually just use the print straight from the bed. There's really minimal cleaning usually needed, and basically you could start stepping paint on almost immediately when the print is finished. For this, the FDM printers, it's generally especially good for large prints. So technology is fairly cheap and scales fairly cheaply upwards. So large print areas are, let's say, easier and cheaper to achieve than with other technologies. So this kind of makes the FDM printers ideally, especially for terrain projects, vehicles, etc., all sorts of larger prints. But it's also a fairly, let's say, slow method of printing. So a mid-sized building like the one on the right that I have done for some sci-fi wargaming, these will easily take far in excess of 100 hours to print, even with let's say slightly more optimized layer heights, which are good enough for terrain but maybe not for miniatures. So of course these printers can always be left to run without supervision, but it's always good to keep in mind that it's not an immediate process where you decide that you want something and in a few hours you will get the finished product. So, and one final thing about say FDM printers that is good to keep in mind is that they are generally fairly easy to upgrade. So you can start off with a cheaper machine, but when you kind of get around, learn to use it better and know what you want, it's fairly easy to start upgrading components to improve print quality, print times, etc. So generally usual upgrades are things like flexible build plates, which make removing prints from the print bed a lot easier, maybe improved cooling to have better control of the printing process and lower noise issues, etc., or then better nozzles, higher quality parts, etc. Then I have a few pictures of different kinds of things that I've been printing. So these are fairly close-up parts, and you can quite easily see some sort of defects that are around on these sort of prints. So the layer lines show up every now and then as the nozzle size is a limiting factor, there's always, especially on things like small details like rivets, you will see some sort of artifacts as the nozzle is moving back and forth and it cannot track the sides of the part and to actually always cleanly execute what's in the 3D model. Also some sort of, quite common to see like on the end parts when the nozzle lifts up from the surface, there's always some sort of small stringing showing. Then a similar terrain piece showing quite that the layer lines can be quite visible, especially if you have an angled surface, as generally always you have the next part layer is always slightly to the side from the previous one, creating layers. But of course these pictures have been taken from a few centimeters away, so if you would take this to a gaming table, then it's probably mostly unnoticeable unless you really go look from a close distance. But it's also possible to get quite a bit, let's say, cleaner detail. So this part has been done with a lot smaller nozzle and lower printing details. So for example, the stairs there, they are 0.5 millimeter high. So this has been a terrain piece for a Games Workshop game called Adeptus Titanicus, showing a sort of a cityscape for where the Titan can be based on. So even this sort of small detail can be achieved with an FDM printer, but of course the print times the finer layer heights, the longer it will take to print. And as a sort of a final example for what can be achieved with FDM printers, so there's a kind of this Hot Wheels car that has been quite heavily modified for a racing game called Gaslands. So all the wheels, the new engine, nitros, the exhaust, they've all been printed with an FDM printer. So you can achieve pretty nice quality even with an FDM printer, as long as you just fine-tune the settings, use a small nozzle, use small layer heights. So it's even, let's say, fairly fine detail for miniatures is achievable with FDM printers. Then to the next technology that is probably, if you're interested in mostly just in printing miniatures, which would then provide with the, let's say, better quality, and which is probably a more interesting option then. So resin printers. There, as I said in the beginning, there are mostly two kinds of resin printers. SLA printers, which show stereolithography, which work with a laser to draw the printed part layer by layer, and DLP printers, or digital light processing printers, which generally use a larger light source below with a screen used to control which area of resin is hardened. And these DLP printers are generally cheaper, and those are what's kind of dominating the consumer market now. So basically resin printers, these function by having liquid resin in some sort of a container that is then just hardened with a light source at a certain UV or wavelength, of light wavelength, which are usually in the UV range. Then let's say these resin printers, at least at the consumer cost level, have not been around for that long. So I would say maybe around for 5 years there have been resin printers that have been at a low enough price point for consumer usage. So there isn't as much experience, and the printers themselves aren't as developed always. But these are at the moment developing at a really rapid speed, and there have been really large advances on the printers even in the last just couple of years. But as they've only been around for a few years, there are still, let's say, a bit more hiccups in the units compared to, for example, different FDM printers, where some manufacturers have been making them for 10 plus years and have been improving during the whole time. For print quality, the quality is generally far better than on FDM printers, but there is a downside. So generally with this technology, the printing areas are a lot smaller than on FDM printers. So if you're on an FDM printer, you are looking at maybe a minimum of 20 by 20 centimeter print area. Then with a similarly priced resin printer, you are probably looking at closer to 70 or 7 centimeters by maybe 10 centimeters print area. So they are a lot smaller, which can cause issues if you would like to print some larger things like large vehicles or large terrain pieces. Then, let's say the major downside of resin printers is that in most cases the materials are hazardous, and especially in liquid form they are toxic. So working with resins always needs quite a few safety precautions. So generally the bare minimum is to wear safety gloves at all times. Ideally you would also be wearing eye protection, some face mask to protect you from any potential fumes, etc. So working with resin printers can be a bit tedious with all the safety precautions, and you will probably also need to sort of have a specified area where you work with the prints, as you will need to have a lot of cleaning liquids around, and you will need to have some sort of waste disposal systems as well. And resin printers, they will always generate quite a lot of liquid waste that needs proper disposal. So pretty much all of the materials, they have to be taken to hazardous materials collection points. Luckily here in Finland it's generally just free. Of course it takes time to take them there, but you can take all hazardous materials there for free. But it's good to keep in mind, so you cannot really dump anything down the drain, etc. Everything all liquid waste has to be collected, has to be sorted through somewhere. And also of note is that the resins, they can smell, and I've noticed it's a bit dependent on the person if they find it irritating or not, but generally it's a very good idea to work in a well-ventilated room to make sure that no fumes kind of escape. For the most part, the materials are generally safe to use when they're hardened, or if the fumes are safe, but it can never really hurt to take it safe and make sure the precautions so that you don't run into any issues. There are some let's say eco resins and stuff like that are a bit less toxic, but even those will still need proper waste handling, and at the moment there's really no way of getting around it. Also, compared to FDM prints, resin prints generally require quite a lot of post-processing work after printing to make them usable. So the prints, they will always have some liquid resin left on them after taking them out of the printer. So the prints really need to be cleaned, usually with solvents like isopropyl alcohol or similar. There are some water washable resins available, but even then you can only wash them in water, but you cannot dump the water down the drain, so they're still toxic. And finally, when you have a clean print with all the leftover resins removed, then they still need usually a final curing with the UV lamp, or of course direct sunlight can do it. But UV lamp, you can usually control it better and make sure that no prints fail from excessive UV exposure. Then, let's say, at least in my experience, compared to FDM printers, resin printers can require quite a bit of fine-tuning, and there are small changes in printing conditions can actually affect printing quality quite a lot. So for example, with the weather conditions we have now, the room where I am printing is maybe 7 or 8 degrees warmer than normally, and that has actually led to me needing to change the printing exposure settings, as the resin cures faster during warm weather than in normal conditions. So things like a hot summer can actually affect your print quality, and these kind of things need to be taken into account when working with resin prints. Then just a couple of example prints here as well. So first off, with the sort of a vehicle, so this is in 28mm scale. I kind of put this here to show that even with resin printers, you are still able to do, let's say, for average size vehicles pretty easily. So this is just one print bed. And of course, with a larger print, you could split it into more sections and just glue it together at a later time. Then, just to show sort of what sort of quality is achievable, so this is a 28mm model for Warhammer 40k, and as you can see, you can do pretty fine details on places like the gas mask containers, the goggles, even small text renders out very nicely. So in general, I would say the pixel size is maybe 1/10 of what's available for FDM printers, and from a layer size, you can go to 1/5 of the, let's say, absolute minimum of FDM printers, but maybe to 1/10 of, let's say, the practical limits of FDM printers. But with a properly set up resin printer, you can get quite close to the same quality, or more or less to the same quality that the store-bought miniatures achieve. And here the layer height is roughly 50 micrometers, but the printer could actually go down to 1/5 of that. But even with this, it's already, from a normal tabletop quality perspective, it's already well and truly good enough. Then a couple of examples of smaller prints. So these skeletons are roughly 10 millimeters high, and like the rib gauges, the holes there, those are maybe 1/4 of a millimeter, and details like these come through pretty nicely with a resin printer. Then finally, to kind of end it, here's the same model printed with both an FDM printer and a resin printer. So we have a resin print on the left and an FDM print on the right. The FDM print has been done with 0.4 millimeter nozzle and 0.1 millimeter layer height, while the resin print has been done with 0.05 millimeter layer height. But as you can see, of course, this is, again, these pictures are really closed up, and I have painted them so that there is a black undercoat with a white from the top to bring all the kind of layers and everything inside. So in reality, it's maybe not as drastic, but as you can see from the resin print compared to the FDM print, especially on small details like his goggles, his fingers, buttons on the jacket, his tie, etc. So all of these smaller details are where the FDM printers will start to especially suffer compared to a resin printer, as just from the nozzle size and how it's moving, it just cannot achieve as sharp details on small areas. But then if you compare like more larger, smoother areas like the trousers, the jacket, etc., there the print quality difference is pretty unnoticeable. And both of them work pretty well on a tabletop quality level. So if you're just looking for a gaming piece, you can achieve it with pretty much both technologies. So which technology choose if you are looking for your first 3D print? So I guess the main question will be, what will you be mainly printing? So if you are looking to do like big terrain pieces, big monsters, big vehicles, etc. for games or whatever, I would first rather look into FDM printing. It's generally simpler, and you can usually print large pieces even in one go without any sort of issue. But if you are looking to just print like single miniatures or small terrain such as furniture, small vehicles, etc., resin will deliver better detail and will be faster. But it's good to keep in mind that neither technology is kind of really fully or completely unsuited for the other tasks. So you can get by doing both with both technologies. Then I would say for a beginner, I think FDM printers can be a bit simpler and simpler to use, or they're easier to use from technology standpoint, and they are easier to use from all sort of the safety precautions. So an FDM printer, you can just basically put on your normal desk, press start, and it can work there without any sort of extra precautions. But for resin printers, you will really need to take the hazardous material into account. And also for FDM printers, it's I would say it's also easier to start with from the point of view that you can even get the machines in like your local hardware stores. For example, Bauhaus sells 3D printers or FDM printers, as well as Clas Ohlson here in Finland. So these are fairly easily sourceable, and you can get the materials in a, let's say, a larger supermarket as well. Then FDM printers, they are a bit cheaper to operate. So I would say material costs are starting at roughly 20 euros a kilo for FDM printers versus around 45 euros a kilo for resin, as you are required to use, or you will need to use different chemicals in addition to just the resin as well. Of course, with FDM printers, you're probably printing larger pieces, so maybe the material consumption can be a bit higher as well. And also FDM printers, spare parts are generally a bit cheaper and easier available. So if something breaks down, if you need to fine tune something, FDM printers can be a lot easier to use. And also to take into account, if you are, for example, you want to be printing with your children, then I would definitely say that it's best to start with an FDM printer, as the safety issues are really difficult to handle if you want to use this with a kid. Then before purchasing, just a couple of pointers, things to take into account. So in the end, still at the moment, let's say most consumer priced 3D printers, they are not polished products and rarely work in a plug and play fashion. So you cannot kind of expect the same sort of quality that you would from normal consumer electronics like a TV or a mobile phone or similar. You will always need some sort of tinkering to make sure that everything works, everything functions well. There will be problems even with a machine that has been printing perfectly for months. They just suddenly start causing some sort of hiccups, which then need to be solved. So some sort of do-it-yourself attitude is needed if you want to get into 3D printing. Then with the printer, as you will always encounter some sort of challenges on the way. The larger the community for a printer, the easier it is to find any sort of help. So especially if you're a newcomer to the hobby, I would really recommend sticking to just the most popular brands, as it will make your life easier, because in general somebody else has always had the same problem before, and you can always find the answer there. And also there's usually better product documentation to lean towards to if you take a large more established brand with a large community. Then something to just consider is, if you're printing, material costs can actually quite quickly become higher than the printer itself. So if you're thinking about your budget, so you can easily quite fastly use far more of filament than the actual printer even cost. So a kilo of filament can go quite quickly if you are really get into printing all sorts of terrain. But in the end, it's still, let's say, 3D printing is not rocket science, so don't give up. Even though, so I don't want to kind of scare anyone by saying that there are problems you need to tinker. This happened, but in the end, it's not too difficult to fix these issues. The technology is fairly simple, and you don't need like a PhD to understand it. So it's fairly still, as long as you just kind of get into it with the notion that you sometimes need to tinker with it. The technology is fairly simple. It can be quite, you can always learn how to fix the machines, how to fine tune it, etc. And even then, I would say after fine tuning, pretty much every machine can run reliably and hands-free. So for example, my resin printer, except for changing the resin exposure settings in the heat wave now, I've been running it, let's say, last 6 months without doing any sort of maintenance. So it is pretty much achievable. When you find a good way to work with it, then the machines, they will work. But it just takes a bit of effort to get there. And finally, before buying a printer, it's always good to remember that you can always easily get started by testing 3D printing at your local library or makerspace. At least here in the Helsinki area, most of the local libraries have a 3D printer where you can just book a time slot, go there, and the staff can also help get you started. So if you are still on the kind of fence about it, it's always a good place to go and test, see if you like it, and then think about investing on a 3D printer yourself. So then I would have some, let's say, recommendations for if you want to invest in a 3D printer. I have a couple of recommendations which could be good choices. These are, let's say, it's not a very long or an exhaustive list, but these are kind of based on machines where I have some experience and where I know that they are good solutions for a beginner to start with. So for FDM printers, I would either go with a Prusa or a Creality printer. So Prusa, and especially their Mark III's, the Prusa is, they are basically the industry leader, and I think they are the most sold 3D printer in the world at the moment. They, the machines already incorporate pretty much all the like recommended upgrades that you would even think of doing yourself on a cheaper printer. And the community is absolutely huge. So, and they are pushing, they have really good product documentation, and they are also coming out with a lot of tip videos. So they are, with the Prusa, it's extremely easy to get set up and to find help if you are needing it. But of course, this comes at some sort of a flip side there is that basically they are quite expensive compared to a lot of the other manufacturers. So in a kit format, the unit started around 800 euros shipped to Finland, and for about 1,000 euros for a pre-built unit. Of course, personally, I would always recommend buying a kit, as building the printer yourself, you will actually learn what goes where, see how it's built. So when you need to service it, it's a lot simpler as you've already done it once. So changing some part or servicing some part will be easier in the future. Then another good option for an FDM printer would be Creality Ender 3. So after the Prusas, I think it's pretty much one of the world's most popular models available. And again, a huge community where you can easily find a lot of help, and especially if you want to start upgrading it, there are so many different modifications and upgrades that people have designed for it, so it's fairly easy to start with start upgrading it to bring it to this level of the more expensive competition. And as it's a more, let's say, simpler, cheaper unit, it's of course quite a bit cheaper than, for example, the Prusa. So costs are roughly 250 euros per printer. Then for resin printers, I would generally recommend Anycubic or Elegoo as brands. So those are some of pretty much the two biggest ones. And I would say in general, there's not much difference between the manufacturers. So both make really good printers, which can work for most cases. Anycubic was, I would say, pretty much the first that became a really big hit with consumer printers about 4 years ago. And they've been then improving the product ever since. And their printers, they cost about between 250 to around 650 euros, depending on the printer size. So with basically the more expensive the printer, the larger print area you have available. So I would say with the 250 euros scale, you can maybe print around 28 millimeter models, and on a 650 euro printer, you can easily fit closer to 30 models to print at one time. Then Elegoo is another manufacturer which is really large and really popular with a good fan base, a lot of good documentation and easy to find help. They have pretty much the same price range as the Anycubic printers, so around 250 to 600 euros. Notice the largest Elegoo is a bit cheaper than the Anycubic one. But regardless of manufacturer, for resin printers, if you are buying one now, I would recommend going with the monochrome screen. They are generally a bit faster, and they are kind of the latest improvement that has been around. And then just finally, so the printers that I'm actually running, so at the moment at home I have a Prusa Mark III S and a Anycubic Photon Mono X. So the Mono X is just the larger monochrome screen version from Anycubic, and the Prusa Mark III S Plus is just the latest Prusa printer with all the kind of upgrades they have done. Then when you've actually bought your 3D printer, then how to get some models to 3D print. So there are quite a few free models around, so there's a ton of hobbyists making models, sharing them for free. I would say probably the two biggest sites for sharing models are Thingiverse and My Mini Factory. So there are just absolute hundreds of thousands of models. So pretty much anything you can think of, somebody probably has modeled it, and you can find it somewhere there for free. Of course, might not be as good quality as with the purchased model, but still it's a good way to get started with. Then a lot of sites are selling paid 3D models that somebody has designed and put up for sale. So again, my manufacturer, it does allow for sharing for free and also for charging for prints. And maybe a lot of designers might have a few like tester models for free, and then they're selling a larger catalog. Then other good sites are Gumroad, Cool's 3D, and then there's a lot of designers have their own web stores around. Then for, let's say, especially if you're looking for maybe a bit cheaper models or by getting them in bulk, so there are other sales channels, especially Patreon is now, there's a lot of different people, companies and people doing designs with a monthly fee basis, so that, for example, you pay 10 euros a month and you get maybe 20 models every month for printing. But of course there you're always signing up for a full month. You might not have much influence of what's coming, so it's always, and there's, let's say, such a large selection that it can be maybe a bit difficult to find what you're looking for. Then Kickstarter is another pretty popular place. So there's generally, I would say, let's say nearly every day a new 3D model Kickstarter starting up, from different terrain projects to different miniatures, etc. So just browse on Kickstarter, and you can, if there is a theme that you like, you can generally get pretty good deals from buying a Kickstarter compared to purchasing models one by one. Then some of my personal favorites for 3D models, let's say most of these have a Patreon page and their individual web stores. So Artisan Guild, a Dungeon Shadow, Titan Forge, those are more, let's say, role-playing game oriented, especially let's say Artisan Guild and Titan Forge. They have generally a themed miniature set once per month, and they also push out adventure that uses all the miniatures that they have designed that you can use in your campaigns. There's also Maker's Cult, which is more like for Warhammer 40k, and Printable Scenery, which is they make pretty amazing terrain for printing, both sci-fi, fantasy, and also just regular modern terrain. But something that can be a bit tricky now, especially as I would say 3D printing is in quite a large boom at the moment. There are huge amount of miniature designers popping up selling models for 3D printing, and with such a large selection, the quality can vary greatly. And something that I've noticed that can cause some issues every now and then is that even an amazing sculpt might not be that well suited for 3D printing. So shifting through the selection can be a bit daunting at times, and you might not be 100% sure that if the great model that you purchased is actually great for printing. Then just quickly about some design. If you really get into it, I would say if you want to kind of get the best advantage out of a 3D printer, it's a good idea to learn some design skills as well, because then you really unlock the freedom of a 3D printer. So for design, I would say Blender is probably the best free tool to start out with. It has a great large community got a lot of good free tutorials, and it's pretty much suitable for all applications, from creature design to some even like designing vehicles or hard surfaces. Then for let's say more like man-built or surf designs, I would say sort of CAD softwares are pretty good as well. For example, Fusion 360 is free and can be a good place to start with. But if you just want to do some small modifications of like existing designs, these things can be achieved even with just a simple software like Microsoft 3D Builder that comes with Windows for free. So it's quite easy to just cut something and copy something else from another model, just modifying what's already been done by somebody else. And then if you don't actually want to get your own printer, but you want to work with 3D prints, there are quite a lot of 3D printing services around. So there's a ton of services popping up that even cater specifically to just gamers. So it's hard to list because there are so many, but if you find 3D models that you like, chances are that by asking the designer, they've already probably sold printing licenses to some company that can actually get it printed out to you fairly easily. So it always pays to ask around, as you can usually find a service that can print things for you. Then some larger stores. So Shapeways is a large 3D printing service that has a massive catalog of designers uploading to a web store there. Then also there's a lot of Etsy stores selling 3D prints from different kinds of models. So if you go to Etsy, Google, you can pretty easily find a lot of different 3D prints. Then for Finland, I just want to name a couple of companies that I know are in Finland and that are servicing the 3D printing community. So Luova 3D, Printtinarri, and Miniluola. Those are all active here and can probably print you. If you share a 3D model, they can probably get it printed out for you. And at least some of them also have printing licenses for different designs. So they already have some sort of a catalog available as well. Then just some final parting shots. So 3D printing can be a pretty great addition to your gaming hobby, just to bring a lot of different options available to modify to truly make your own designs. But just please be prepared to spend some time tinkering with it and don't get like disappointed if there are some challenges on the way. And like I said, don't be discouraged by challenges, but just experiment bravely. So there will always be challenges, but they can always be overcome, and they're generally fairly easy to overcome, and you can get some pretty nice products in the end. And I would say in general, the 3D printing community is very welcoming and helpful. So at least whenever I've had any difficulties, it's always super easy to find help around, and people are generally very welcoming of newcomers. So that would be that. So thank you, and I will be then answering any questions in YouTube and Discord after this. So, but thank you for listening, and hope you have a good Ropecon.